Welcome back to Neural Intel. Today, we're diving deep into the technical details behind building a code editing agent.
Yeah, we're looking at this paper, well, more like a guide, How to Build an Agent, amp.pdf by Thorsten Ball.
Huh.
It basically argues that building one of these agents isn't, rocket science.
Right. He says the core is really just an LLM, a loop, and enough tokens.
Yeah,
And that the impressive stuff we see is often down to solid engineering, not some secret sauce.
exactly. And what I found really interesting is the claim you can get a basic but working agent going with under 400 lines of code. He actually gives you the code snippets to try it.
So our mission today is really to unpack those technical bits and pieces, see how it works under the hood.
Let's do it.
Okay, so starting point. The paper stresses this isn't revolutionary tech, right? It's using existing LLMs, but in a specific structure.
That's the key. The basic structure is a loop. User says something, it goes to the LLM. They used Anthropic's Claude here. The LLM responds. You process that, and around you go. That's the agent's heartbeat, sort of.
And a really important technical detail is how context is handled. The whole conversation history goes back each time.
Every single time, yeah. Because the server itself is stateless. It doesn't remember anything from one interaction to the next.
Ah, okay. So sending the history is the workaround,
Uh-huh.
which means managing that context window becomes, well, pretty crucial as the chat gets longer.
Absolutely. It's a core engineering challenge right there. The first code example, about 90 lines of Go, just sets up this basic chat loop with Claude, showing exactly that process.
Okay, basic loop established.
Uh,
Then the author brings in tools. What does he mean by that?
so an agent, according to this guide, is an LLM plus tools. These tools are what let the LLM actually interact with the outside world, maybe change things. It's not just talking anymore, it's doing.
Right. It moves from just processing text to actually, interacting with an environment. He uses an analogy like a wink.
Yeah, kind of like telling the LLM, hey, if you need to use function X, just give me this specific signal, like a wink, and that signal triggers the tool.
So the flow is LLM signals, then something outside the LLM runs the tool.
Exactly. The LLM says, I want to use tool Y with these inputs. Then the agent framework, or maybe even the user initially, runs tool Y, gets a result, and feeds that result back into the conversation for the LLM.
Okay, makes sense.
Yeah.
And model providers are building APIs for this now.
Yeah, they're making it easier to define these tools formally.
Let's make it concrete. The read file tool. How do you build something like that?
Okay, so every tool needs a few things. A name, obviously, a description for the LLM telling it what the tool does and when to use it, an input schema, usually JSON schema, defining what info the tool needs, and of course the actual code, the function that does the work.
And for read file.
It's pretty straightforward in the Go example. There's a tool definition struct holding all that info. The actual read file function just takes a file path, uses Go's standard os.readFile, and returns the content as a string.
So the LLM doesn't need to know how to read a file from disk, just that it can ask for the content of a file called, say, main.go.
Precisely. It abstracts away the implementation details. The JSON schema is key here too.
Why the focus on JSON schema?
It gives the LLM a strict format for its requests. For read file, the schema says, you must provide a path which is a string, no ambiguity. It helps ensure the LLM provides the right info so the tool can actually run.
Got it. And the main communication function, run inference, needs to be aware of these tool definitions.
Yeah, you pass the definitions along with the user message, so Claude knows what tools are available in that turn.
Okay, tool defined. How does the agent actually, run it when the LLM asks?
The agent's main run function is updated. It checks the response from Claude. If it sees a specific content type like too loose, it knows the LLM wants to run something.
And that triggers the execute tool function.
Right. That function gets the tool name from the LLM's response, finds the matching tool definition, pulls out the input parameters the LLM provided, runs the actual Go function for that tool, and captures the output.
And then that output goes back to the LLM.
Yep. It's packaged up as if it were a new message from the user, saying something like, okay, I ran the read file tool, and here's the content, file content. So the conversation continues, but now the LLM has the result of its action.
The example shows Claude using read file to look inside secret-file.txt. What's the significance there?
It shows the LLM making the decision itself. The user asked, what's in secret-file.txt? And Claude figured out, oh, I have a read file tool, I should use that, without being explicitly told step by step. That's the agentic part.
Okay, next tool about list files. Purpose.
Lets the agent see what files and folders are in a directory. Same setup, definition, input schema, the actual function.
How does the list files function work?
It uses goFilePath.walk function, which is standard for traversing directories. It collects the names of files and subdirectories. One neat detail is that it adds a trailing slash to directory names in the output.
Why the slash?
Just makes it easier for the LLM to tell files and directories apart when it gets the list back. The output is formatted as JSON.
And then we see Claude using list files and read file together.
Right. That's cool because it shows simple planning. First, it lists the files to see what's there, maybe finds go.mod. Then it uses read file on go.mod to answer a question about the Go version being used. It's chaining tools together.
Makes sense. Okay, the final tool, edit file. This seems like a bigger deal.
It definitely is. This allows the agent to actually change files on the local system. Again, it follows the pattern, definition, input schema, and the edit file function.
How does edit file work? Is it complex?
Surprisingly simple in this implementation. It reads the file, performs a basic string replacement, finds all occurrences of old str, and replaces them with new str and writes the result back.
Just string replacement. Not analyzing the code structure or anything?
No, not at this level. It's a direct text find and replace based on what the LLM specifies. It also has logic to create a file if it doesn't exist, and the ultra is empty. There's a helper create new file function for that.
And the examples show it doing what?
First, creating a completely new file, fizzbuzz.js, with some JavaScript code, then modifying that same file to change the loop's range, and finally creating another file, congrats.js, this time with code to decode a ROT13 string.
So it demonstrates creating and modifying code, even if the modification method itself is simple string replacement.
Exactly. It shows the potential, driven by the LLM's ability to generate the correct parameters for the edit file tool.
So stepping back and looking at the whole architecture, the loop, the tools, what are the main takeaways here?
I think the biggest one is how simple the core concept is. An LLM, a loop, and a way to call external functions. That's it. The really advanced agents we hear about, like AMP itself, build on this core with much more sophisticated engineering.
Like better prompting, maybe ways for the agent to get feedback, better UIs, managing many tools.
All of that. Handling errors, edge cases, maybe having the agent reflect on its plan, but the foundation described here is surprisingly basic.
And it really highlights how capable current LLMs, like the Claude 3 family mentioned, are at figuring out how and when to use tools to solve a problem, even without super explicit instructions.
Definitely. This deep dive into Thorsten Ball's approach really demystifies things a bit. It shows that powerful code editing agents can stem from combining a good LLM, a simple interaction loop, and these well-defined tools. It opens up a lot of possibilities.
Yeah, the fact you can prototype something functional in, under 400 lines, that really speaks volumes about how accessible this kind of LLM integration is becoming for developers.
So for listeners, maybe think about your own workflows. Seeing this basic structure, does it spark any ideas? How could you maybe use an LLM with a couple of simple tools to automate something technical in your world?
It's definitely food for thought. We encourage you to check out the concepts, maybe even play with the code structure if you're inclined. What kind of tools would you add? What problems could you tackle?
And for those interested in keeping up with the latest AI and ML research generally, do check out our webpage. The link's in the bio. Hopefully this technical breakdown was useful.
We think so too. Join us next time on Neural Intel for another deep dive.